Unit dimensional analysis. We are on page 6. For those of you who might have accidentally gotten the wrong thing, the page number is on the bottom left. Please make sure that it is correct. Okay. Some of you may notice that there's difficulty scrolling because your hand is in the middle of the screen. If you want to scroll up and down on your page because you don't have it vertical, let me just forewarn you, vertical is a lot easier to see the whole page with. If you don't have it vertical, then you have to scroll in the white. Okay, on the right-hand side, there's a white bar. You can scroll up and down using that. Okay, so either way is fine by me. I don't care. But we're going to get started. I'm going to just start out reading this so that you can start understanding the language that is going on in this book. So understand, it says, when solving a problem, it is important to correctly identify the units being considered measured. This may require converting a quantity given one unit or a different unit. So to do so, use conversion factors. We've already discussed conversion factors. So such as 12 inches per foot or 0.001 meters per millimeter. To write the multiplication expression, be sure to set up the conversion factors correctly so the result is stated in the appropriate units. Now normally I won't read that, I'll just explain in my own words. Okay, but I want you to be able to understand what it's saying and how it's being read so that you, if you miss, are able to go back and look at it. So if they give us these multiple problems, they're going to show us how to do it within the text. I'm going to write down the problem and show you how to do it just on our notes. Okay, so if you ever need another reference, you can go back, look at the text, and go from there. Okay, so we have 1,023 meters, and each of the 1,000 meters, 1,000 is the prefix kilo, right? There is 1 kilometer for every 1,000 meters. So this is your unit factor. Okay, remember, unit means 1. Unit means 1. If you don't remember that, write it down. Unit means 1. Okay, the question asks us to convert 8 meters to kilometers, or more specifically, it says pay attention to the units. It can ensure that you perform the conversion correctly. Remember, there's 1,000 meters and 1,000 kilometers. That's our unit conversion here. It says convert 8 meters to kilometers. So I have 8 meters. I need to convert it to kilometers. Remember that any number by itself is literally only over 1. Okay. So in this conversion, I have to stagger or opposite my units. So if I have meters on top here, I need meters on bottom over here. So you'll notice that your unit conversion must then flip. We're allowed to do this because this is only equal to 1 no matter which way you read it. So 1,000 meters over 1 kilometer is the same as 1,000 meters on bottom and a kilometer on top. Okay? So remember that every unit conversion can be written flip-flopped as well. The biggest mistake that I see people do is they have this 1 unit conversion and they're like, oh, that's how I convert, and then they put it over here and they multiply straight across and they get 8,000 meters or 8,000 kilometers in 8 meters, which is completely wrong. That's backwards. So you have to remember to make these opposite. So we get 1,000 meters on bottom and 1 kilometer on top, and then we just go ahead and multiply straight across. Cancel out the things that are opposite of each other and then write it straight across. So here we get 8 kilometers per 1,000. Okay, we need to write that in a form that is much better. You will notice that in the book, what did they do? The very first example. What did they do wrong? They multiplied straight across, but look where they have meters. They have meters and meters, right? They did what I told you was the most common mistake. If you'll notice, it's really hard to do with that big glare in the middle of my screen. You'll notice, look, they have meters and meters. They did not flip-flop them. So they're first showing you, basically, that this is not correct. So you got to be careful. You have to actually read in this book. Don't just go through there, oh, okay, that's how it's done. There's the example. Because look, they showed you first the wrong way to do it. So it's very important that you realize that they're going to show you the right way and the wrong way. Okay? So don't just go when you miss a day, oh, that's how it's done. First example, okay? Make sure you read it, because right below it says the unit result is meters squared over kilometers are not the appropriate units. Okay? So you have to be careful. And then they show the proper way to do it right below. Notice that they show your marking out, and then it shows you the answer that they get. So at the end, and get back to my adjustment here. It'll brighten up, I swear. It says 8 divided by 1,000. So when I get that result, it's really 0.008 kilometers. I ran out of paper. 0.008 kilometers. I want you to write it down in units that make sense. I'm not going to ever say, you probably won't ever say 0.008 kilometers, to be honest. You'll probably just say 8 meters. But you're never ever going to say 8 over 1,000 kilometers, right? You might say 8 1,000ths of a kilometer, which is how you would read this. There were a few of you on your test there that I had trouble finding your answer. I wasn't sure which one was your answer because I had several numbers by themselves. It will be very beneficial to you for your success and your safety, if your parents are anal about grades, that you circle your answers when you get them. Alright, the next problem says that we need to add 7 centimeters to 1 inch. Okay? If we're going to add units, they have to be like units. So I need to convert either centimeters to inches or inches to centimeters, whichever is easiest for you, unless the problem specifically asks us to convert it to 1 unit. So let's read this problem and see what it asks us to do. It wants us to... Dimensional analysis can aid when in writing equations by determining how certain quantities can be combined. For example, to add or subtract 2 quantities, they must be expressed in the same unit. So let's just do it both ways. It doesn't specifically say, so I'm going to do it both ways, and you can decide which way is easiest for you. So if I'm going to add these 2 quantities up, let's first say that we're going to convert centimeters to inches. Okay? Does anybody remember the conversion from centimeters to inches? 2.54. Yes, it is. So here's the shorthand conversion. 2.54 centimeters, right, because centimeters are smaller, is in 1 inch. So I'm going to set up my conversion using that right there. So if I have 7 centimeters and I want to convert it to inches, then I need to stagger those centimeters, 2.54 over 1 inch. Okay? And then I just multiply straight across. My centimeters cancel, which is exactly why I set them up that way. I get 7 divided by 2.54. Somebody with a calculator tell me what that is. And then, of course, don't forget your unit. It's in inches. Somebody with a calculator, please. I should say everybody with a calculator. Everybody should be doing it. Okay, I'm going to round that to 3 decimal places. Tell me that in 3 rounded decimal places. 755. Does everybody else agree? Had a calculator? This is a very collaborative class. I would like an answer. Yes, thank you. So, 7 centimeters is a little over 2.5 inches. So now I take this unit conversion, because I have it in inches now, and I'll just plug it right in so that my 7 centimeters is now representative of inches instead of centimeters. And then that's really easy to add. That's fairly obvious. We just get 3.755. Now this is approximate. So if you ever do an approximation, please write the approximation symbol. Let me make that a little prettier so you can see it. It's just squiggly equal signs. That's the best way I know to describe it. Squiggly equal signs. Okay, so 3.755 inches. Now if we wanted to go the other way with this, I'm going to have to use my unit conversion again, but I'm going to have to flip it the other way. Well, now I already know what 1 inch is, right? 1 inch is 2.54 centimeters. Simple. I can just plug her in and go with that. So I have 7 centimeters. I'm going to add it to my 1 inch, which is really 2.54. And that would give me 9.54 centimeters. Okay. So these answers are equivalent. They should be exactly the same. If I was to take 9.54 centimeters and divide it by 2.54, I should get 3.755. Okay? They should be exactly equivalent. They are one and the same. Now, typically the question will specifically ask you for your answer in inches or your answer in centimeters. So be careful when you're reading these to make sure that you are able to do it. Alright, the next one. Suppose you eat 3 apples per week. So I'm going to go ahead and write that down as I'm reading it. 3 apples. Remember per is that division sign right there? Per week. 1 week, right? Alright, so I wrote it down as I read it. How long does it take you to eat a bag of 12 apples? The answer would be in some unit of time. Can you solve this by multiplying 2 quantities? Now, everybody should know that we need to do what with these 2 numbers? If I have 12 apples and I ate 3 a week, what am I going to do with my 2 numbers to find out? I'm going to divide, right? It's fairly obvious. So this is a good practice of a problem that we know the answer to. The answer is 4, right? It takes you 4 weeks. A good example of a problem that we know the answer to that we can check whether or not we understand how to do this. Okay? So remember that when you get problems that are really easy, it's not necessarily so that they can give you an easy problem every now and then. It's so that they give you an easy problem that you know the answer to and you can self-check your work at the end. So make sure you do it the way that we're learning, but check yourself using common sense. Okay? So it said 3 apples per week, and it said I have 12 apples in total. So we said that this is a unit conversion, right? 3 apples per week. So this could go one way or the other. So when I go ahead and multiply this straight across, I need to find out how to do that. If I have 12 apples, can I use a unit conversion that says, can you solve by multiplying these quantities? Yes or no? So if I use multiplication, I'll put a multiplication in here. The only little bit of information that they gave me was apples, right? 12 apples. So I'll plug in that 12 apples because there's not really a unit conversion for apples necessarily. So when I multiply this straight across, I'll get 3 times 12, which gives me 36 apples, which of course does not what? Doesn't make any sense, right? I multiplied apples times apples, so I actually have apples squared per 1 week because I multiplied the bottom pieces too. I have to multiply straight across. So I look at this already and go, well, this is silly. Okay, so we know that that didn't work. We can't use multiplication to do that. So just like y'all guys said at the beginning, if we have 3 apples per 1 week, we need to divide, right? So we can divide that by our 12. So if 3 divides by 12, we get we get 0.25. This is again apples. So I get 0.25 per week. Again, well, week. Okay, and again, my answer don't make sense. Okay, so this is that process of elimination. If you get an answer that don't make sense, go back and rethink what you did. This is that easy problem that you can use to understand the right way to do things. Now, yes, we have to use division, but what way do we have to use our division? It's always the quantity, right? The quantity, which was 12 apples, divided by the rate that we use them, right? So everybody knew that we needed 12 apples divided by 3, but it's 3 apples per 1 week. Now, this is where some common misconceptions go in. Everybody knows that the answer is 4 weeks. It's fairly obvious. But how do we get that answer using this math? Well, you can't really divide fractions, right? You have to do what? You have to flip them and multiply, right? So if I have 12 apples and I'm dividing it by 3 apples per week, I really have to multiply by its reciprocal, right? The reciprocal is what you're talking about when you say flip. So let's start changing our language to the proper reciprocal, because those are the words you're going to see on the testing, you're going to see them in the book, and words I'm going to use. So let's get used to seeing those and using those. So I flipped it. Now you should notice something. Okay? You should notice apples cancel. We get 12 divided by 3, and the unit is in weeks. So the answer, of course, was 4 weeks, which we knew from the beginning. But we could use this as a very easy problem to realize that our answers were not making sense at the beginning. Okay, any questions about that? Very serious question here, guys. Just give me a show of hands. Me showing you all of these improper ways, does that confuse you guys? Show of hands if it confuses you. A couple of people. I will be experimenting with different ways to do that. Because you need to realize that sometimes when you do the problem, you need to self-analyze whether or not this makes sense with the problem. So I want to show you those things, but at the same time I don't want to confuse you. So if we get way lost on something that I'm showing you, just shut me down so I stop doing it. I don't want y'all to be lost when we're in explanation mode. So do not feel bad about raising your hand and saying, this is getting me so far lost, and I'll shut it down. Okay? Keep me in check, and that will help you, I promise. All right, go ahead and flip the next page, 7, if you're not already there. This is a connect problem. It's supposed to be real world. Typically it is. As you get higher into your math, it may not. If you zoomed in on your page and you're having problems flipping pages, zoom back out and then flip your page. That might help you. Okay? So, here's the problem. A police officer saw a car traveling 1,800 feet in 30 seconds. Seems fast. The speed limit on the road is 55 miles an hour, and this guy wants to know if they're speeding, I bet. Was that car speeding? So first of all, I'm going to do the problem the way that I'm going to do the problem. Y'all guys have your book as another resource on things to look at. Okay? So 1,800 feet in 30 seconds, I want to convert that to miles per hour. So this is a double conversion here. I have 1,800 feet per 30 seconds, and I need to convert feet to miles. So let's write that conversion up here. How many feet are in a mile? I did not understand that. 5,280 feet. Okay, so there's our unit conversion. I'm going to deal with feet first. I'm going to completely ignore the seconds for right now. I'm going to deal with feet to miles right now. So using this information up here, I'm going to put feet on bottom, so it's 5,280 of those over 1 mile. Can we agree that we have our unit changed from feet to miles? Yes. Thank you, Colton, for being the only participant. Everybody make sure you're answering. All right. Next, I'm going to completely ignore everything else. So basically, I would be ignoring everything except for the 30 seconds. Okay? It's supposed to be in hours, right? So if I come over here and I write what I want my answer to look like, I wanted it to be in miles per hour, then I need to get rid of these seconds. Now, if you know how many seconds are in an hour, rock on. You can do that conversion in one step. However, most of you may not know that. So I need 2 unit conversions for this. How many seconds are in a minute? Right. And then how many minutes are in an hour? And if we knew the total conversion, it would be 3,600, by the way. So if you know that conversion, you can go ahead and use it instead of doing the multi-step thing that I'm about to have to do. Okay, so again, seconds are on bottom. I need seconds on top here. So I have 60 seconds in 1 minute. I'm just using the information from this guy. And then my next one, so I've got rid of seconds now. Now I need to get rid of minutes. So minutes is on bottom. I'm going to put minutes on top to get rid of that. So I have 60. I wrote that as seconds again in my unit conversion. Silly me. Sorry. 60 minutes in 1 hour. Now you should notice at the end, if I got what I asked for, my hour is the only unit listed on the bottom. Let me get that a little higher for you guys. Hour is my only unit listed on bottom. Miles is my only unit listed on top. Then I'm going to multiply that straight across. I'm going to get some ridiculously large number that's not going to make sense, and then I'm going to have to go ahead and convert that to a thing that makes sense. Okay, so I have, remember, everybody should have a calculator or do it in their head. 1,800 multiplied by 60 multiplied by 60. $66 million. Oh, whew. That number got a lot bigger. All right, 6 million. Say it again. Anybody disagree with that? Did not leave myself enough room here. Okay, and then on bottom I have 30 multiplied by 5,280. Okay, I'm just multiplying straight across, right? That's too big. That's a number that makes sense. Okay, then I have to take these two quantities and divide them. I already noticed that I don't need to divide as big of a number as I thought, but
you wrote the number down, it's 158,400.
oh, you said 400? Oh, I didn't hear you say that. I'm sorry. Thank you for correcting me. 158,400. I'm sorry. So what do I get when I divide those two numbers? Hopefully it's less than 55 miles an hour. Otherwise this guy's getting a ticket.
I got 40.9, so I round up to 41.
40.9?
I got 40.909090909.
Repeating?
No, I got 40.
Yeah, your calculator will automatically round after 8 decimal places.
Well, I got 20.90909. That's exactly what he said.
Your calculator will round. He did.
The one that
Okay, so it was 40.90 repeating, right? So I want to remind you, repeat end is this thing's name. Okay, so if I was going to write an exact answer, which I am in this case, it's 40.90 miles per hour. So he was going 40.90 repeating miles per hour. The 90 is what's repeating, so I put that repeat end over both of those numbers. The name is pretty self-explanatory on that one. So, to answer the question, it says, was the car speeding? No. Simple, right? If it asks you to elaborate on that, you say no. The car was doing approximately 41 miles an hour, which is 14 miles below the speed limit, right? So, he actually could get a ticket for going too slow. Did you know you could get a ticket for going too slow? So, here's an interesting problem. Y'all guys all know cars are rated by their fuel economy, right? Miles per gallon. Everybody should know that. So, everybody hears or sees on TV MPG, right? Miles per gallon. But do you really know what it means and how to calculate it on a car? Some of you probably do. So, what is miles per gallon? It's fairly obvious when you write it down. Miles per gallon, right?
How many miles do you go on?
How many miles you can go on 1 gallon. But does your car, does every car, some cars do, does every car tell you how many miles you go per 1 gallon? No. So what do you got to do to find out that information?
You have to divide how far you travel by how much.
So how many miles you've gone by how many gallons you used. How do you find out how many miles you've gone? Check your odometer. So you either check your odometer for the trip, which will tell you how many miles you've gone, or if you don't have a trip, because you have a 69 Mustang that doesn't have that kind of stuff, then you have to take your odometer at the beginning and subtract it from your odometer at the end, and that'll give you that difference. Okay? So back in the day, before they had trip counters, you actually had to subtract it. So you basically would take your miles. So let's play a little bit of a game. So if I traveled from here to Portales and then back, I'm going to travel approximately how many miles? About 50, right? So I'm going to go ahead and write 50 miles in there. Now on my Mustang, I'm going to get approximately, this is an approximation, okay? I don't know exactly, 2.2 gallons spent doing that. I'm going to use 2.2 gallons doing that trip. Okay, so I want to know how many miles to the gallon my Mustang gets. It's an old car, seeing if it's more economical than my truck. So, I take 50 and I divide it by 2.2. What do I get? Somewhere in the 20s, I'm sure.
22.17.
So I can have another repeat end?
Yeah.
So here, it's miles over gallon, so I'm going to write miles per gallon as my end. So just an interesting use of units being read the way they need to be read. Now, there's another interesting problem that if any of your parents or relatives are truckers, that they have to do kind of constantly. A trucker in the heat of the summer will leave their truck running at a rest stop to keep the air conditioner going. If you don't keep your truck running, then you can't keep your air conditioner going. So they sit at an idle for a long time. They need to convert how many gallons they use at an idle to how many hours they can actually keep their truck running without running out of diesel or without using too much diesel. Because if diesel costs $4 a gallon and you're using 6 or 7, 8 gallons in a night just to sleep, it might have been cheaper just to stay at a motel, right? So that's a cost analysis that they want to do. If it's cheaper to stay at a motel, don't you think they'd probably rather stay at a motel? Yeah. So that the kind of rule of thumb that my dad gave me when I went on the truck with him is you burn about a gallon of diesel every single hour that you're at idle, which is really not that bad when you consider how big those motors are. So if you look at his, 1 gallon is equal to approximately 1 hour that he can sleep. Now, I don't know if you know much about truckers. They have to take... Well, do you want to sit in 120-degree weather in Arizona? Yeah, me neither. So, the 1 gallon per 1 hour, they have to be at rest. You don't necessarily have to sleep. You just can't be moving your truck for 10 hours. You are not allowed to move your truck for 10 hours over a certain time period. It's illegal because if you drive for 24 hours straight, you're going to wreck a semi that weighs 80 tons. It's just bad juju. Okay, so this is a really easy conversion because it was 1 gallon. Now, the example from the book says that it burns, so I'm going to change my 1 gallon. This is my dad's general rule, okay, so he just approximates this. The book says that at an idle, it'll burn 0.82 gallons, so not a full gallon per hour. So the interesting part of this is now we have to convert and figure out how many gallons he's going to use in that hour. And then we'll take those gallons and figure out whatever the cost of diesel is to see if it's cheaper. Oh, he's already got an answer for us. So let's just see how we do it. What did you do, Wesley?
0.85.
Oh, it doesn't really matter. It really doesn't matter. We're just going to do the problem. Sorry. So when we just had 1 gallon, the answer was fairly obvious. In 10 hours, we're going to burn 10 gallons because, well, it's just 1-for-1 exchange, right? But now when we have 0.82, the problem becomes a little more complicated. What do we have to do? Well, it's very similar to our apple problem. So if we have 10 hours and we need to get rid of hours, we're going to go ahead and multiply it by that unit conversion that's over here. So I need to stagger hours. I have 1 hour for 0.82. Now, before I solve this, let me just see if we even got this set up properly. Let's think about what our answer might be if we finish solving this, right? Our hours would cancel, I'd multiply straight across, I'd get approximately 8.2, right? Does that sound like an answer that makes sense? If we're using less gallons per hour, will I get, because remember our original was 1 gallon per 1 hour, and we'd use 10, would I get an answer that makes sense? 8.2. Yes. Why? Because it's smaller, right? So it makes sense that my answer would be smaller than the original one if I would have rounded it up to 1 gallon. Okay? So you can use approximation to double check yourself and make sure that you're doing the right thing. So 8.2 gallons. So if you use 8.2 gallons in a 10-hour period, and diesel, when my dad was truck driving, was actually I think it was $3.89 or something like that, a gallon. Well, let's just go over here. $3.89 per 1 gallon. So again, I have another unit conversion. So I need to take 8.2 gallons and find out how much it costs for him to sit at idle. So fairly obvious, but I want to remind you why the gallons go away. It's because they're staggered like that. So 8.2 times 3.89 is what? 8.2 times 3.89, that's where I should be here, and calculators are clicking away, is what? So I heard this answer, which sounds reasonable, all but for one reason. Has anybody ever gone to the grocery store and they said your total is $31.89 and 8/10 of a penny? It'd just be 90 cents. Why? Because we rounded first. We rounded this up, which would make that a 0, which would make us have to round that up, so it becomes that 90, right? 31.90. So it costs about $31.90 to run that truck at idle. I don't know very many good motels that you're going to get to that aren't roach infested that are $31.90 a night. So cost analysis says it is a lot cheaper for him to run that truck for 10 hours at idle than it is to go to a motel. Now, if you put in the cost of repair for to run that truck and put the use on it, it may not be the same. But for direct analysis of that, it is cheaper to go ahead and run it. All right, flip our page. There's a couple more examples, but because I went ahead and expanded on these, I'm going to skip them, okay, because we've already done several of those similar examples. But we're going to jump into example B right here. We've got another type of skill that we need to work on. It says the hospital's records indicates that on average 23%, I'm writing down the important information, 23% of babies born are delivered by cesarean section. A total of 217 babies, 217 babies were born last year, and a total of 220 born this year. So this is, I'm going to put last and 220 this just as a note for myself. Okay, so 25% or 23%, sorry, are born via C-section, and last year. This is page 8 in your book. Example B, if you want to write that down. Okay, so 217, this is just a note for myself. If you need more of a note, write down 217 babies last year. You can write down that long thing. 220 babies this year. You can write down that long thing. That is A-okay. Alright, there's a two-part problem. It says, what should be the expected number of babies born by cesarean section over both of these years? So first of all, I need to find 23% of 17. What operation do I need to perform here? What does of tell you to do? It tells you multiplication, right? But I can't multiply 23 by 217 because that's going to give me some ridiculously large number, and there are not that many babies born there. So what do I got to convert? Right, I have to convert this percentage to a decimal. How do I do so? I move it twice to the left. In other words, I would divide it by 100, right? If you're not familiar with this, make sure you write down divide by 100. Divide by 100. Okay? So now I can take this decimal, 0.23, and multiply it by 217, which will give me the amount of babies, approximately, that were born via cesarean section last year. So, take 0.23, multiply it by 217, everybody, lottie-dottie. Say it again. Now, why does this answer not make sense? Challenge accepted. No, I'm just kidding. That's funny and not funny all at the same time. So, what should I do because I can't have 0.91 of a baby? I would round up, right? Is there ever a time where I should round down? If it's below 0.5, I would say go ahead and round down. Okay, so 50 babies. There's my label. Now I need to find out how many babies we're going to be born this year, approximately, via cesarean section. Since I already did that conversion, I'm going to go ahead and do it. 0.23 multiplied by 220. Now, because we already did the last problem, on this one we should have approximately the same, right? Somewhere between 49 and 50 something. 50.6, rounded up, 51. So, looking at those two answers, it's to answer their question, you want to make sure that you answer it exactly the way they asked you to. What should be expected for the number of babies born by cesarean section over both years? So to answer the question, about 101. It's a bunch of mamas getting cut open. I know, when you say it like that, it's not as cool. Any questions about that? Okay. Flip the page, ladies and gents. Flip the page. Page 9. This is example C. I'm going to go ahead and just read the problem. Start studying that graph on the right as I read this to you. Problem, example C. The table on the right shows the quarterly profits for a company over a 1-year period. Quarterly meaning the years were cut into fourths. Make a bar graph to display this data. So bar graphs, first of all, I'm going to do a small little example of what a bar graph looks like. Bar graphs have bars. Right? Everybody should remember that? Verizon. It's like those little things that are sometimes on your phone. No? Nobody? Okay. Was it AT&T? It was AT&T. Sorry. Anyways, we're going to create a bar graph after this. Now, there are some very important things that I want you to take note of when you're creating a bar graph. 1, I need a title. Okay? That's the first thing I'm going to look for. So this said that chart was quarterly profits. So I'm going to make the title quarterly profits. Then I need to identify my axis. So my bottom has got to be something and my top has got to be something. So normally the x-axis, which is the one that is straight across like this, horizontal, typically goes for some sort of time measurement. Okay? And then whatever's left ends up going over here. And this is normally some kind of quantity measurement. So the y-axis is normally some kind of quantity. Okay? So just make that note. Y is normally quantity, x is normally time. It's not always, but it's normally. Okay? X is always your input. I'll tell you that. It is always your input. And Y will always be your output as a result. But X is always, always, always your input. Alright, so looking at our chart, which column in that chart, remember it says quarter and profit, which one of those is a time? Quarter, right? Because profit is clearly not a time. Even if you didn't know what a quarter was, you would be able to tell that it's a time because, well, profit is not a time, right? So the quarters, I'm just going to label them along my x-axis. 1, 2, 3, and 4. Then I need to decide what this label is. So I'm just going to write quarter because that's what it was. The quarter in a year ends up happening every 3 or 4 months. Then over here, I'm going to label this other axis my profit. Now, I need to know what my profit is in, and in this case, it's in dollars, so I'm just going to put a dollar sign, profit in dollars. And then I build my graph. Now, looking at my profit, it's 167, 232, 97, and 124,000. Okay, so my profit, should I make it in thousands, or should I just go ahead and write it out every single bar here, 100 and whatever something thousand, 200 and whatever. So I should probably go ahead and write this as in thousands to make my life just a little bit easier. Okay, this is the main point. We'll pick up on this. And then we needed labels, and that's as far as we got yesterday. So I wanted X and Y axis, and then I wanted labels. So next I want to talk about what our increments are going to be. So take a look at your charts on the top right-hand side of page 9. Okay, so on the top right-hand side it says quarter and profit. We had decided that we were going to put this in thousands. So meaning that we're just going to look at the first 3 numbers in that chart. So really, we're dealing with 167, 232, 97,000, or 97, sorry, and 124. So my smallest number will be 97. My biggest number is going to be 232. Now I need to figure out, obviously I'm not going to start at 0, so there's going to be a break in my graph. So go ahead and do the little jagged line thing to show that there is a break. Why is that not moving? to show that there's going to be a break in your graph. So go ahead and do your jagged line. Show that there's going to be a break in your graph because you're not starting at 0. We're going to jump right on up to something close to 97. I'd say we should start at either 95 or 90. What do we need our increments to be? Remember that I don't want to make a huge, crazy graph.
50,000.
He says you want to go up by 50. Anybody else got an argument with 50? Okay, so if I'm going to go up by 50, what do I start at? You want to start at 50? So if we started at 50, let's just run this down. Okay, if we started at 50, we'd have 50 be our first mark. We'd have 100. We'd have 150. We'd have 200, and then 250, and that'd probably be our last mark. So we'd only have 5 increments on this entire thing. Is that detailed enough?
No, go up by 10s.
Tens? Tens might be pushing it, but I think tens is going to be at least a lot more accurate. Okay? So if we're going up by tens, what should we start at? 90. So I'm going to go ahead and mark right here and put 90. Because this is in thousands, all I have to do is write 90. And then if I'm starting at 90, I need to count how many I'm going to be going up. Okay? So as I say these, count on your fingers or put a tick mark or something, how many increments we're going to need. So 90 is the first one, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. I need to go up to at least 230, right? So 210, 220, 230, and if I have room, I'll go 240. But I need at least 230 because I have a mark at 232. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, lots of marks. If you went up by 20, it would be half, right? We need 8. You always want to change it from 10 to 20? Okay, we can do that. So we'd only need 8 marks now. We'd still be pretty detailed, and we'll have a little bit more room to look. So we starting at 90. We're going to go up by 20. So I'm going to go up 110, up 130, up 150, up 170, up 190, up 210, and up 230, and I'm going to go all the way up to 250 because I had room. That way I can show my marks. Now, in between each one of these, just to help me out, I'm just going to put a little tick so I know where halfway is. And that'll help me find the tens part. Alrighty. I like 20. I like 20. Because I write big on my numbers, and it would be a lot more difficult to go by tens for me. Okay. Do what one suits you, but you have to have a detailed enough graph. So choose a proper increment. Alrighty. If you have a straight edge, I highly suggest that you use a straight edge. It'll help you immensely. So when I say straight edge, I just mean a ruler.
Do you have any rulers?
There are some in there, but I prefer for you not to use them. You all have note cards or should have note cards. A note card is a perfectly good straight edge. Okay, so you can just use the bottom of a note card. Here, I'll even do it. Show you how you do it. Bam. So as I'm using this, I'm going to go from top, and I'm going to be able to see my bottom. So here's quarterly. Quarterly starts at number 1. The first quarter was 167. So I'm going to go to where I think 167 is. Here's my 160. I'm going to be a little bit bigger than half, so I think it's going to be right about there. So now I have my straight bar across, and there it is. I know that my bar has to be that high. Okay, I'm not actually going to build my bars yet. I'm going to go ahead and do all of the data first. So on number 2, I have 232, so I'm going to go to 230. And there's my 235. Just below that, about midway, it's going to be 232. So again, that's going to be right there. On my number 3, I have 97.5, which is going to be right in between 90 and 100, just above the halfway mark. It's going to be right there. My last one's 124, approximately 125, because it's actually 120.